Okay, we'll do few basic terms related to spherical lenses. In our previous class, we discussed about the concave and convex to spherical lenses को विषयमा we discuss no. Now we'll do few basic terms. अब few basic terms spherical mirror को विषयमा what we have to remember that we'll do. First we'll do the center of curvature. First center of curvature. What is center of curvature? A lens, either a convex lens or concave lens, is it's a combination of two spherical surface. Each of the surface forms a part of sphere. The center of these two sphere are called center of curvature, and it is represented by C1 and C2. अब के रहेछ center of curvature? You have to remember एउटा कुरा याद गर्नु पर्यो, either convex होस् concave lens होस्, दुईटा नै it's a part of sphere. हामीले डल्लै यसरी यहाँ हेरेर यो फिगर्स हेरेर यसलाई पनि यसरी एक्सटेन्ड गर्यो, यसलाई पनि यसरी एक्सटेन्ड गर्यो भने विल गेट द स्पेयर. अनि त्यसलाई नै that means your C1 and C2, that is the center of sphere. Center of these two sphere are called the center of curvature, and it is represented with C1 and C2, and this is same for both concave and convex lens. Number 2, that is the principal axis. What is principal axis? Imaginary straight line passing through the two center of curvature. This center of curvature is the line draw and this line is called the principal axis. Clear? Number 3, that is the optical center. What is optical center? The center point of lens is its optical center. यो lens को either convex concave को बीच को point line we call optical center, and it is represented with O. A ray of light when passes through O, it remain undeviated, it goes straight. तिमीले ray of light यो center बाट pass गर्ने, it will deviate it and it goes straight. Converge पनि हुँदैन, diverge it will deviate it. Clear? Same. Now number 4 is aperture. What is aperture? The effective diameter of the circular outline of the spherical lenses. That means the lens तिम्रो either concave convex कत्रो छ, that diameter is the aperture, we called it. Clear? Now number 5, we have the focus of lens. Lens को focus. When you'll pass beam of light passes parallel to principal axis after refractions from, अब यहाँ two possible दुईटा convex को लागि focus of lens will be the different. First we'll do for the convex lens. अब convex lens मा if you'll pass a beam of light parallel to principal axis के हुँदैछ, we know convex lens it will converge the ray of light. हामीले pass गर्यौं भने just look at this figure. अब यो figure हेर त, यो figure मा के हुन्छ, converge to the point a principal axis. Principal axis मा गएर it will converge, the ray of light will converge, and it is denoted by F. Your F is called the focus. Clear? यो चाहिँ for the convex lens, because it will diverge. If you pass a ray of light, so many rays of light, if you pass it, it will converge and form in one point. That is the F. This F2. And यसलाई we call the focus point. Diverge गरेर एउटै point मा पाउँछ. अब यो त अर्को example हामीलाई याद छ. I'll give you the example. Sunlight मा you just give a convex lens. Okay, sunlight na convex lens rakha. Okay, that should be parallel rays from suns. Then what happen? Will get the image of the sun on the papers will get, and that after some time what happen, that paper start burning, and that paper will start burning, you know? That means that will converge the ray of light. The ray of light converge gare that start burning. That is the example. Converge the ray of light. Now likewise number 2, concave lens मा चाहिँ के हुन्छ, appears to diverge. हामीले भन्यो concave lens ला अर्को के हुन्छ, diverging lens. यहाँ नि यो फिगर मा it will diverge, ray of light पास गर्छ तर छट्टा रेन्ज एउटै जग्गामा गएर उयो हुँदैन, के हुँदैन, कन्भर्ज हुँदैन, फोकस एउटैमै जाँदैन. It will diverge the ray of light. Now appears to diverge from a point on the principal axis known as principal focus. That means त्यहाँ उतापट्टि गएर कन्भर्ज हुँदैन, यतैपट्टि आएर यहाँनिर त some way it will meet, तर it will diverge the ray of light. The distance OF2 and OF1 is called the focus. अब यहाँनिर OF2 and OF1 we called it the focus we called. Now next what you have to remember, tips for drawing ray diagrams. This we have to do with the ray diagram. Okay, now ray diagram you have to remember, number 1, after reflections a ray parallel to principal axis will passes through F. अब तिमीले if you pass a ray of light in any तिमीले ray of light pass गर्यो अरे क्लियर लेन्समा रे अफ लाइट पास गर्दा के हुन्छ, आफ्टर रिफ्रेक्सन गरेर द्याट रे अफ लाइट प्यारलल टु प्रिन्सिपल एक्सिससँग प्यारलल तिमीले रे अफ लाइट पास गर्दैछौ भने चाहिँ आफ्टर रिफ्रेक्सन चाहिँ द्याट विल पासेस थ्रु एफबाट के हुँदैछ, फोकसबाट पास हुँदो रहेछ. अब नम्बर 2 मा द वाइस वर्सा उल्टा, अब रे अफ लाइट तिमीले एफबाट पास गर्दैछौ भने आफ्टर रिफ्रेक्सन के हुँदैछ, द्याट विल कम्स parallel to principal axis and parallel हुँदो रहेछ. Just look at this figure, this will happens. Clear? Okay, we'll do the image formation by lenses. First we'll do the image formation in lenses using ray diagram. Okay, first we'll do for convex lens, how the image will formed by the convex lens. For that you have to remember the nature, positions and the relative size of the image formed by convex lens for various positions of the object. For the this we did for the lenses also, for the mirror also, and for the lenses also will do what types of what will be the nature, what will be the position and what will be the size of the image formed by the convex lens. First we'll do for the convex lens. Just look at this table. We'll do this table and one by one we'll discuss using the ray diagram. Okay, just look at this table. First column is for positions of the object, second is positions of the image, third is relative size of the image, and last one will have nature of the image. Clear? Suppose you have keep the object at infinity. हामीले object लाई if you keep at infinity, the position image हामीले कहाँ form there is at focus f2. Clear? f2 focus मा form हुँदैछ. Just look at this figure. We are discussing for the convex lens only. Just look at here this convex lens. This is the convex lens. Clear? Of your convex lens ma, if you'll keep the object at infinity, हामीले अब यसरी नै यो object infinity मा राख्यो भने image कहाँ form हुँदो रहेछ, at focus f2. अर्को साइड मेरे at focus f2. Here will get the positions of the image. And the relative size, कस्तो हुन्छ size भनेपछि highly diminished point size, highly diminished सानो हुँदो रहेछ point टक्क मतलब यहाँ त टक्कै टिक मात्रै छ नि f2 मा. The size of image will form and the nature of the image is real and inverted. Real हुँदो रहेछ अनि inverted उल्टा हुँदो रहेछ. अब सेकेन्ड मा चाहिँ object beyond 2f1 focus to f1 यहाँ हेर्दा यो फिगर्स मा यसको बीचमा राखेर beyond 2f1 मा राख्दा चाहिँ positions of the image हामीले कहाँ पाउँदो रहेछ, between f2 and 2f2. Just look at here figure. यहाँ बीचमा हामीले image पाउँदो रहेछ अनि image is highly diminished. Diminished. सानो हुँदो रहेछ image is diminished. Clear? And the nature of the image is real and inverted. Image के हुँदैछ real and the inverted. अब next मा at 2f1 तिमीले यो यहाँनिर राखेर object at 2f1 मा राखेर यहाँ राख्दा हामीले position of the image कहाँ form हुँदैछ at 2f2 मा f1 मा राख्दा कहाँ form हुँदैछ f2 मा focus 2 मा. Clear? किन focus 2 छ यहाँनिर? Because there is two spare हैन, दुईटाको center is different हैन, त्यसले गर्दा center of curvatures, त्यसले गर्दा focus point also will get the 2. अब हामीले 2f1 मा राख्दा position of the image कहाँ पाउँदैछ 2f2 मा पाउँदैछ and the relative size of the image is same size, जत्रो object छ त्यत्रै image पाउँदो रहेछ and the nature is real and inverted. अब next मा हेर, if you'll keep the object between f1 and 2f1 and 2f1 मा राख्दा you'll get the position beyond 2f2 यहाँ फिगर मेरो beyond 2f2 मा पाउँछ and enlarge image is ठुलो हुँदो रहेछ object भन्दा image ठुलो enlarge and the nature is real and inverted. Clear? अब next अर्को केमा रहेछ fifth मा at focus मा राखेर f1 मा राख्दा हामीले कहाँ पाउँदो रहेछ at infinity ma will get the positions of the image infinitely large or highly enlarged. Infinitely large kotro भन्नु सक्दैन रहेछ and the nature is real and inverted. Nature कस्तो रहेछ real and the inverted will get. Clear? अब now अर्को रहेछ between focus f1 and optical center O. अब यहाँनिर फिगर मेरा त between f1 and optical center मा राख्यो भने we will get the image on the same sides of the lens as the object. Clear? Object जहाँ राख्यो त्यही साइडमा के पाउँदो रहेछ इमेज पाउँदो रहेछ अहिलेसम्म हामीले ब्याक साइड कन्भर्ज गरेर पाएको थियौँ कन्भेक्समा हैन अनि रिलेट साइज कस्तो हुँदो रहेछ एन्लार्ज ठुलो अनि nature of the image is virtual and erect which cannot be obtained on the screen. Clear? Erect and which cannot be obtained on the screen. Screen मा सक्दैन enlarge ठुलो हुँदो रहेछ. Clear? This is the ray diagram for convex lens and this table you have to remember. अब तिमीले यो remember you have to by heart this table. That means object कहाँ राख्दा कहाँनिर image form हुन्छ अनि image कस्तो size हुन्छ र nature of the image कस्तो हुन्छ. That is very important. You have to remember this thing. Clear? And these are the ray diagram we discuss. Well, you have to remember it. Okay, next we will do image formations by concave lens by using the ray diagram. This also you just go through this table first. Here we'll get the nature, positions and the relative size of the image formed by a concave lens for various positions of the object. Now here also first table we have position of the object, second position of the image, third relative size of the image and last one we have the nature of the image. Here for the concave lens only we have the two possibilities. Okay, first one, if you keep the object at infinity, the position of the image will be at focus f1. Clear? At focus f1 ma will get the image and the size of the image is highly diminished and point size सानो टक्क मात्रै पाउँदैछ that is point size and the nature of the image is virtual and erect means which cannot be obtained on the screen. For this you just look at the ray diagram. In this ray diagram just look at here, this is the concave lens. If you keep the object at infinity, तिमीले concave ma infinity ma object rakhane will get the image at focus and this point will get the image f1 and the size of the image is point size and this is the first possibilities and the second possibilities. Now in the second possibilities we have between infinity. If you keep the object between infinity and optical center O of the lens, then we'll get the image between focus f1 and optical center O and the size of the image is diminished and the nature of the image is virtual and erect. Just look at here for this the ray diagram. Look at this is the concave lens. If you keep the object at that means we'll keep the object between infinity and optical center. Infinity र optical center को बीच में राखें हामीले image चाहिँ यहाँनिर पाउँछ. Just look at here between focus f1 and optical center O. अनि size चाहिँ कस्तो हुन्छ diminished सानो size हुँदो रहेछ and the nature is virtual and erect which cannot be obtained on the screen. There's two possibilities you have to remember for concave lens, and for the convex lens we did the 6 possibilities, isn't it? 6 correct you. And for this concave only 2 possibilities are there. To know the nature, positions and the relative size of the image. These tables also you have to by heart. And in the next class we'll do the sign convention for spherical lenses. Clear?